So we're going to go ahead and take a look at the H2 reflection properties of binomial distributions. And while I'm at it, why don't I just go ahead and pull up a packet so you can see what the notes look like on that. So what page is that? So the notes start on this year anyway, so start on page 9. All right. So some of the key things you'll need is this mu equals n times p. So I'm going to put that on the scratch work for the H2 reflection, which the link to my scratch work is included in this. There we go. So there's H1 and H2 reflection. That's not what I want. H2, make it blue. Reflection. All right, so some of the key things we want, I'll just kind of screen capture them out of the packet. So we need to know that mu equals n times p. That's important. Copy. Actually, let me just copy it this way, get the whole sentence. Assuming, I hate it when those things pop up. All right, capture. There we go. Formula for expected value. We're going to need that. That's in your notes. All right, so we'll need that piece. And we'll also need, let's go to it, make sure, yes. So I want to make sure this is written a little backwards in a way because I'm showing you the skewed, but this is an important, actually it might be on the next page. Do I have it? The conditions? No, that's my best bet at conditions right here. So the conditions are, these are like opposite conditions. My apologies. I'm realizing that later. It's like, oh, I gave them opposite conditions. So when things don't work. So we'll put that and put that in our scratch work as well. So in other words, let me add a clarifying note here. Want NP at least 10 successes. That means NP is at least 10. And want at least 10 failures. That means n times 1 minus p. In case you're wondering what q is at least 10. To use the normal approximation. So that's the big part of our assignment today. All right. So, okay. Go away thing. There we go. So let's go to our problems. For which of the following values of n and p is a normal approximation appropriate? I'm actually going to go ahead and just copy this problem in. We don't have a lot of problems today. So what we're going to do is we're going to go ahead and go n times p and n times 1 minus p for each one of these. So n times p equals 30 times 0.6, which is 18. So that's good. All right. N times 1 minus p, or here's your shortcut. N times 1 minus p, I could multiply it out, or I could just subtract the number of successes. So sometimes that's easier. 30 minus 18 equals 12, or 30 times 0.4 equals 12. So both of those work. All right. So this one's fine. So it looks like this one is the appropriate one right here. Okay, maybe scrambled on your choices. Let's look at why the other ones aren't appropriate. So NP here for the second one is 100 times 0.07, which is 7. Bad, not at least 10 successes. So I don't even have to check anymore there. Now, you're probably going to notice that this next one looks good. NP equals 100 times 0.95, which is 95. That's fine. Now, let's do n minus times 1 minus p. Well, that'd be 100 times 0.05, which is 5 successes. Failures, I'm sorry. Not enough. All right. So, not enough there. Okay. And then we have this one here, 30, NP is 30 times 0.8 is 24. But you can probably guess, so that's successes, expected successes. So expected failures equals 30 minus 24 equals 6, not enough. All right, And then here, if you go n times p, you find out that 15 times 0.5 is 7.5. Not enough successes. So the only one that works is our very first one, which is n is 30 and p is 0.6. All right, so we'll go ahead and click that one. For a binomial model, what is the z-score for x equals 58? So this one is just kind of revisiting the binomial distribution. All right, so it helps to know what the binomial distribution equation is. So it's the, let me go ahead and put the problem in my Scratchwork so I can remember what problem I'm trying to figure out. So the expected value, we just need the expected value and the standard deviation. All right, so expected value equals mean equals n times p. All right, so in this case, it's going to be 80 times 0.7, which is 56. Now, standard deviation is a little more tricky. Standard deviation for a binomial is, I'm going to need the formula here because I got to do a square root. Square root, where are you, square root? There we go. Oh, I accidentally clicked here. I wanted to still be in my text model, sorry. I needed to click equation from up here. So I'm going to put a square root. Where are you, square root? There you are. Go away. So it's n times p times 1 minus p, also known as q, depending how you do it. All right, if you take AP stats, we tend to just use the 1 minus p. We don't ever use q. One of the old AP stats books I used had it. So it's 80 times 0.7 times 0.3. So if I Google equation that, all right, so square root, here's how you can do it, square root of 80 times 7 times 0.7 times 0.3. Let's see if it worked. Oh, no, I think it did square root of, okay, so let's see. 80 times 0.7. So if you're using a cheapo calculator, like a Google calculator, by the way, I need to take the square root of that. So square root of 16.8, 4.10. 4.10. So standard deviation. So be careful with the cheapo calculators. Even Google will throw you off if you're trying to use it to do a quick calculation. You need to make sure you multiply all three of those and then take the square root of that. And then z-score, all right, so z-score equals, and hopefully you remember the formula, it's value minus mean, or data point minus mean divided by SD. So in this case, it's going to be our value is 58 minus our mean, which is 56, divided by 4.10. So it's 4 divided by 4.10. It's very close, not quite 1. So I can pretty much say, oh, it's this one right here, right there. Okay, that's the z-score. So let me go ahead and click that. And I guess I'm on the right track because I'm getting some of the right values. Below, for a binomial model with n equals 80 and p equals 0.7, below what value would be considered usually high? I mean, above. I need to change that to above, by the way. So basically, unusually high. So for number 3 is 2 SDs above the mean. So we're just going to take the mean, which is 56, plus 2 times 4.10. So you got 56 plus 8.2, which should be 64.2. All right, so let's go see what my choices are. Oh, let's try 64.2. And then we have unusually low. So I do the same idea. Unusually low is more than 2 SDs below the mean. So we want to do 56 minus 2 point, right? Or basically 56 minus 8.2, which should be 46.8. Yes, so 46.8. And, oops. So I don't see 46.8. Let me see. Did I? Oh, I think I have an error on here. So give me a second. Let me make sure I did that right. So scratch word. 56 minus 8.2. Oh, you know what? It's 47.8. It is 40. I did not have a goof on there. I had a goof right here in my brain because I was thinking 55 already, and that's how I got 46.8. But let's check. 56. I'm sorry, what was it? Oops. My scratch word. 56 minus 8.2. Sometimes that's 56 minus 8.2. Yeah, 47.8. So we'll say right there, hit submit answers. And, oops, what did we miss? What is the z-score for 58? Ooh, let's go double check. All right, z-score for 58. 58 minus 56, that's 2. Mrs. Overman can't subtract. She's very good at other things, but not so much subtracting, apparently. I can multiply and square with the best of them, but adding, subtracting, 4.49. So let's go do that. There we go. Let's try that. And boom, now we got them all.